Hello and welcome to this week's Power Channel TV. This week we're going to dive more into the fuel injection aspect of things here again, and we're going to have our continuation of our diagnostic trouble code explanations. So this week we're going to be working on the O2 sensor, heated oxygen sensor, P132 and P133 codes in particular. So early on in the program here we talked about the 0032 and the 0031 codes. Those were more in the realm of the heater element of the O2 sensor itself, because we talked about then that the heater aspect of it is the most common failure point of the sensor itself, not so much the part that is sniffing the exhaust and making a determination there. So first off, we need to talk a little bit about the theory here of how an O2 sensor works here, and really sort of what it's there for in terms of it being a sensor. All right, and then we're going to dive into the longhand troubleshooting. So I'll show you some tips and tricks on how to troubleshoot the circuitry with back probe pins and a voltmeter, and then we'll jump over to the laptop software at that time, and then we'll look at the findings there. All right, so first off here, the O2 sensor. We only use one in the entire exhaust system for our engines. It is basically looking at the sum of both cylinders inputting into the central chamber of the muffler. So it needs to see that the total exhaust volume to get a correct, accurate portrayal about how the engine is using the given air and fuel ratio that was applied early on just based off of calculations. So within certain operation modes, what we call closed loop, okay, just keep in mind that closed loop is something that is not on all the time. It's not on through warm-up. Takes the engine from about whatever starting temperature it was at up through 125 degrees of engine head temperature. At that point, it can decide to engage closed loop if it's some other criteria has been met or other thresholds have been achieved. At that point, it will start using the O2 sensor to monitor the excess oxygen or excess unburnt fuel in the exhaust stream and make a decision to let the computer know, or the ECM know, if it's gravitating from a specified number. And that specified number is 14.7 to 1. That's stoichiometric. In other words, the perfect burn ratio for gasoline and fuel, or gasoline and air. So you have 14.7 parts of oxygen for every 1 part of fuel. In theory, that gives you the perfect ratio where all you have is carbon dioxide and water basically coming out as an end result. And you're sort of in that sweet spot where carbon monoxide and hydrocarbon and NOx are all sort of contained at lowest level possible. So when things start to drift away from that target number, the O2 sensor is smart enough, okay, and basically through its data it inputs back, can tell the computer, hey, you need to make a change upstream. I'm seeing something different down here. So it has the authority through fuel trims to basically have enough correction upwards of 25% fuel it can add to make up a difference, or it can take away up to 25% of the fuel to make sure that the engine is constantly staying in its sweet spot for operation and performance in closed loop. Otherwise, when it's in open loop, it's ignoring the O2 sensor. It doesn't matter what it says. It's not going to be in use, okay? So, now, in simple terms here, diving into a little bit more of the theory aspect of how it works, it's very simple. It is like a miniature generator. It has some precious metal, a piece of zirconium inside of it that reacts with the hydrocarbon molecules that are coming in with the unburnt, the slight amount of unburnt fuel that's in the exhaust. And when it reacts with the hydrocarbon molecule, it makes a small amount of electricity. Now, it's so small, in fact, that it's rated on a 0 to 1 volt scale. This is what we call a narrow band type of oxygen sensor. Wide band is 0 to 5 volts, much like the rest of our sensors on board. This one works 0 to 1 volt, or 0 to 1,000 millivolts. Okay, so that's what we would be reading. Output from this in is actually in millivolts. So based on that voltage feedback number, the lower the number, the leaner the mixture, the more excess oxygen there is. The higher the number, the closer we get to 1,000, the more rich the mixture is. There is more unburnt fuel in that exhaust stream. All right, so the troubleshooting element of this here. Let's talk about the longhand portion of this. So I'm going to end up using the back probe pins here. And looking from the top down here, you'll be able to see the plug I'm working on. This is our heated oxygen sensor plug here, and it's a fairly bulky type plug. Now the camera angle we're working with today isn't very conducive to what I'm trying to show you. However, there's a gray wire with a black stripe right here that I'm going to back probe first. That's our actual sensor output from the O2. So now I'm going to go ahead and back probe the 5-volt reference, or the ground wire right next to it. All right, hook those up to my voltmeter over here, and then we're going to take a look at the readings. Then once I get this up and rolling here, I'll show you what this begins to look like after the engine's been running. By the way, you will get no voltage readings out of this system without it running. So start up the meter here. This is just a default value of 472 millivolts. It's typically what you see at open air. Okay, so we'll go ahead and we'll fire up the board here. And within about 15 to 30 seconds or so, we should see this drop. All right, so now we're in that, I got a little bit of an intermittent connection here, but we're basically pulling down about 280 millivolts right now. Okay, the lower the number, the leaner the mixture. Okay, now contrast to this, the running engine would be around 800 millivolts or so, 750 to 800 millivolts in normal cases. Okay, that's typically what you're going to see there when you begin to do this test. So again, that's basically how we do this with the voltmeter and so forth here, is with the back probe pins. You back probe the gray wire with the black stripe and then the tan wire, and you look at it through the meter there and you're looking at millivolts. So it had the default number of about 500 millivolts or so, and then it came down to about 280 millivolts while it was running. Again, this system does not begin in place until the engine is actually running. So when I turn the board on, it's thinking it's running, it engages the O2 sensor heater, and then things begin to react. All right, so let's take a look at this other element on the laptop software here, which basically alleviates you from having to back probe anything here. You can look at that voltage raw coming right out of the sensor. So let's take a look at the laptop software. Okay, so we need laptop software. All right, there we go. All right, so you'll see over here there is a value here of HO2S sensor 1. The default value that shows up on the scanner is this 1014.8. Okay, so that's the number that shows up whenever the O2 sensor is inactive. So I'm going to start the board. Okay, and once it begins to run here for a short amount of time, we should be able to see this number change. There it goes. It's starting to drop out. And the longer we let it run, the more the heater engages. And now we're starting to fall into that 280 millivolt range or so that we saw before. So you can see this by using this function here, it takes a lot of the guesswork out of then having to back probe and so forth. So again, on a normal running engine here, you're going to see this anywhere from typically mid 700s up through mid 800s, depending on whether it's an open loop or closed loop. All right, that is typically what you're going to see. If you see it this lean on a running engine, you either have a dead cylinder and it's pumping air through the system and it's skewing the O2 sensor reading, or you have a another issue going on there, like an exhaust system related problem, like a crack or something like that. So that's what we would see on the laptop software itself. So just like anything else, with the voltage being high or low with our trouble codes, you typically will set a high voltage code and then you're going to set a low voltage code. So in this case here, typically what you're going to see is the voltage will have exceeded X amount of voltage here. I don't know the exact specs off the top of my head here, but it's close to that 1000 millivolts for X amount of time. It's going to throw the high voltage code. And then obviously when it gets down to too low of a voltage number, it's going to throw the low voltage code for the heated oxygen sensor element here, okay? So that's how we're going to end up with the code. Now, other things that could drive it that low of a voltage number primarily are exhaust system problems. That is the number one thing that can skew an O2 sensor, and you have to treat it with some care here, because even the slightest crack in the exhaust system or opening will skew the readings pretty drastically. And it's going to cause the engine to run poorly too, because usually it's going to end up in the computer adding excess fuel, and it doesn't need it. All right, so the engine ends up running pretty poorly because of that. So things to look for in the muffler itself: any cracks or soot leaving areas on the muffler itself, whether it be the outer halves of the muffler, whether it be a rolled edge or it's welded, as well as the bung or the threaded port that the O2 sensor sets into. Look for any tracing of soot coming out of there. That is your indication that you have a leak there. Now, I know it may be a little bit contradicting in your mind that, well, there's always exhaust coming out of there. Why would it get fresh air in there? Think about it this way. Every time one cylinder pumps its exhaust gases out and it leaves the muffler, it creates a vacuum inside the muffler in its wake as it leaves. It creates a scavenging effect that helps pull the incoming exhaust out of the cylinder on the opposite side of the engine, and it is now coming around to its exhaust stroke and helps to scavenge and clean out that cylinder better. Well, at that same time, when you create a vacuum in the muffler, fresh air has an opportunity to go in. It finds its way across the tip of the O2 sensor and ends up causing a garbage in, garbage out scenario here, where you are feeding it bad information because it's skewed from fresh air. Okay? The other things that you could have problems with are your exhaust gaskets, where the flanges meet the cylinder head itself. If those graphite gaskets are torn or damaged, or something's wrong there, that is also another entry point. Okay, so those are the big things that you could see here to cause this particular problem. Other than that, the system's pretty robust. Typically, unless you have all the resistance go away inside the sensor, it's typically the only time you ever see it set the high voltage code. The low voltage code can come from either a lean operating condition or some internal resistance that's through the roof, okay, in that circuit. Other than that, that's about what you need to know to troubleshoot this. So we are going to jump off to questions now. All right, welcome back. All right, we have one question from Seth in Wyoming. Is the EFI software available, and how much is the cost? Seth, yes, the EFI software is available. You would order this through your central distributor, which would be what was Mag Power or Power Distributors now. Part number is 19628. Approximate dealer, list price is, not dealer cost, but list price is about $160. All right, that looks like it's it for questions. So again, you can look for this airing to show out on the Power Portal on Monday, and it'll again complete our library aspect here for codes. So again, thank you for taking the time to sit with us here this Friday, and we'll see you again next Friday.